Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. Information about it is at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for exam IFM, Investments and Financial Markets, for June 23rd, 2018. You are given the following information about the two-asset portfolio. The Sharpe ratio of the portfolio is 0.3667. The risk-free rate is 4%. If the portfolio were 50% invested in a risk-free asset and 50% invested in a risky asset X, its expected return would be 9.50%. Now assume that the weights were revised so that the portfolio were 20% invested in a risk-free asset and 80% invested in a risky asset X. Calculate the standard deviation of the portfolio return with the revised weights, assuming the Sharpe ratio remains the same. So let's write R sub x for the random rate of return of the risky asset x. If a portfolio has a fraction W invested in the risk-free asset and 1 minus W invested in risky asset x, then its Sharpe ratio, well, the Sharpe ratio is always the risk premium divided by standard deviation. So in this case, it would be, the rate of return of the portfolio, which would be W times R sub f, W times risk-free rate of return, because that's a portion invested in the risk-free asset, plus 1 minus W times expected return of asset X, minus RF, because that's how we get the risk premium, divided by this standard deviation, but because the risk-free asset doesn't have any variance or covariance, it's only the risky asset portion, and its variance would be the coefficient 1 minus W squared times the variance of Rx. And of course the square root of that would be 1 minus W times the square root of the variance of Rx, standard deviation of the rate of return of a risky asset X. And the top, once we combine the like terms, becomes 1 minus W times E of Rx minus Rf, and you cancel out the 1 minus W from the top and the bottom, and you see that for any portfolio created out of a risk-free asset and this risky asset, the Sharpe ratio is the same as it is for the risky asset. And it's a key insight. The Sharpe ratio of the risky asset X is the same as any portfolio created with that risky asset and risk-free cash-like asset. So the Sharpe ratio has this key property that it is unchanged by leveraging or deleveraging. A very important point to remember. Now, if the portfolio is 50% invested in the risk-free asset and 50% in the risky asset X, its expected return is 0.5 times the risk-free rate plus 0.5 times the expected return of the risky asset X. But we know it to be 9.50. This is an equation in which only one thing is unknown. That's E of Rx. So E of Rx is calculated as 2 times 9.50 minus 2%. 2% is 0.5 times 4% the risk-free rate. And 2 comes from having to multiply both sides by 2 to get rid of 0.5 in front of E of Rx. So this is 15%. Now, since the Sharpe ratio is 0.3667, 15% minus 4% divided by standard deviation of rate of return of X is 0.3667, so that we get that standard deviation to be 15% minus 4% over 0.3667. It's almost exactly 30%. So the portfolio 20% invested in the risk-free asset and 80% invested in the risky asset X has the standard deviation of 0.8 times that 30%, or 24%, and that's answer E. Please remember, this is copyrighted material. The problem itself belongs to a society of actuaries. The solution is mine. Good luck in your studies and good luck on the test.